Hi, this is Mrs. Slater, and the quote of the day is from Mark Twain. It's not the dog in the fight, it's the fight in the dog. Okay, so we're going to talk about polynomials today, and polynomials are going to include equations that have x to the third, x to the fourth, x to the fifth. So the degree is going to be much higher than the quadratics we've been dealing with. Okay, these 5 things that you see, roots, zeros, factors, solutions, and x-intercepts, all mean the exact same thing. Where the graph crosses the x-axis. Okay, so if you know that, I think it'll make it easier to understand when the directions on your homework or your quiz or your test are going to say these things. So keep in mind the format of what your answer should look like. If it's a root, if we're going to name it, we're going to say x equals -3. You can see that right here. Negative or +1. And in this case, we got a 4. The same is for zeros. You can write them with x equals and then the 3 of them with commas. The factors are a little different. So you can take a 0, and if you set it equal to 0, you're going to get its factor. So we would say x plus 3, x minus 1, if you do the same thing for the other two, and then x minus 4. Solutions, we go back to what the roots and zeros look like. And then for the x-intercepts, we know that those are points, so we're going to have to label them as an ordered pair. All right, so when you're in doubt on homework, I want you to come back to this page and just remember like which one is which. All right, let's go to the first example. Okay, and in this example, it's asking what are the roots. So again, where does this graph cross the x-axis? Or is 2 a place where it crosses the x-axis? Where is 2 where it crosses? Okay, so that's really the question here. Now, if you can say yes to this, it's because you plug in 2 for x, and if it equals 0, then it's yes. Okay, so if you don't get 0, then you know it's not going to work. So I made a little typo. You do not need that equals 0 at the end. It's kind of was like a question mark. Does it equal 0? So let's go ahead and plug it in. 2 cubed minus 2 times 2 squared minus 2 plus 2. And after you add all that together, you get 0. So yes, we can say that indeed 2 is a factor. The next one's a little trickier, but we're still going to do the same thing as far as putting 3 plus I everywhere we see an x. Squared, and then our job now is to multiply and add and distribute and do all that all together, and then we're going to combine like terms. So let's go ahead and refer back to Pascal's triangle. Okay, this goes back in the day, but you're going to like the shortcut. Remember, anything to the cubed is going to be, and this is just for 3 plus I cubed. You're going to like it. So we know that the basic numbers for anything cubed is going to be 1, 3, 3, 1. Okay, and then I'm going to change some colors here. And we take 3 and cube it, 3 and square it, 3 to the first power, and 3 to the 0 power. Okay, and then for the next one, we know that I starts at 0, so we're just going to multiply it. I to the first, I to the second, and then finally I to the third. Now, if we put all of this together, it's going to be 27. If we put all this together, it's going to be 3 times 3 squared, which is 27, and I. And then this one is 3 times 3, which is 9, and I squared is negative, so I'm going to put -9 here. And then 3 to the 0 is 1, 1 times 1 is 1, I cubed is -I. So if I combine all my like terms, I'm going to end up with 18 plus 26I. Okay, now I'm going to take that information and bring it right over here underneath my cubed binomial and start doing some more of the work here. So this is a foiling, so it'd be 2 times 9 plus 6I, don't forget the outside and insides, minus 3 minus I plus 2. All right, and I'm going to keep simplifying until I can decide if this is 0 or not. Minus 18 minus 12I, erase that, minus 12I, and then minus 2, so that would be a plus 2 because I squared is -1. All right, and now I can add a whole bunch of like terms together. I've got 18 and 18, they're gone. I've got a 2, negative 3, and a 2. So that gives me a total of 1. And then the last like terms would be this 26. Let me go ahead and get you a different color here. 26 minus 12 minus I. So that gives me a total of 13I. Now, is it 0? No, it does not equal 0. Therefore, it is not going to be a root. Okay, let's go ahead and go on to the next one. Using synthetic division, determine if the following 2 is a root of the polynomial. Again, we're asking for roots. So you can get rid of that negative 0 and determine if 2 is a root. We're going to use synthetic division. So this, once again, goes back into the past a little bit. And if you recall, when you're trying to figure out if it's a root, we can just put a 2 in that box. All right, and then our coefficients, 1, negative 2, negative 1, and 2, we just take them from the polynomial itself. And our song that we always remember, we're going to drop the 1 like it's hot. Here we go. Number 1, and then 1 times 2, 0, 0, negative 1, negative 2, 0. So hopefully that all came back to you very quickly. And notice that your remainder, again, think back, the remainder equals 0. So therefore, that's a little symbol for therefore, 2 is definitely a root. So that means it works out very nicely. Okay, so and then the next one, it's very similar, but I'm giving you in factored form. Again, before we get started, go ahead and get rid of that equals 0. And we're going to use synthetic division. So in this case, we're going to go ahead and set that equal to 0, and that's what's going to go in the box. So hopefully you remember that. 2, negative 3, 1, and negative 1 are going to be the top numbers. Drop that 2 like it's hot, and then we got to multiply and add. Multiply and add, multiply and add. And then this is not going to work because we are getting a factor, or we're getting a remainder that's not equal to 1. I'm sorry, to 0. So this is not a factor. X minus 1 is not a root. Sorry, I'm not saying that correctly. Okay? So it's not a factor, not a root. Different ways you can say that, and I did that wrong here. So go ahead and say it's not a factor. Okay, let's go on to the next one. Okay, use synthetic division again. Oop, there it is. Okay, so then determine if the following x minus 3 is a factor. I want you to go ahead and push pause and practice this one, and then check your answer. So in the, don't forget, set it equal to 0. You get x equals 3, so that's what's going to go in the box. We got 1, 2, negative 11, and negative 12. Drop that first number, and then you're going to add and multiply and continue adding and multiplying until you see that you have a 0. So what does that mean? It means that x minus 3 is a factor of the polynomial. Now, what I mean by the polynomial is this original equation right here. Okay? So you got to keep thinking of that. Let's go on to the next one. And again, push pause, see if you can get the answer. Go ahead and set this equal to 0. So 2 is what's going to go inside here. I do want to mention now, this is the one with the case of the missing term. Dun, dun, dun. So you have got to be careful when you write the coefficients down, because there's an x cubed, but there's no x squared. So we're going to have to replace a 0 in that spot. And then we have 1, and we have 10. And then if we drop that 1 and keep adding and multiplying, we end up getting 10. And then for a answer of 20. So what does that mean? It means that x minus 2 is not a factor. Okay, and again, when you're doing your classwork tomorrow, make sure you're paying very close attention for that case of the missing term. Okay, now the next one is going to be a little different just because we're going to have to do long division. I know, groan, but let's think about how to do this. Long division, because you are not given a degree of 1. So we're going to have to go ahead and use long division, and that's going to go in the front, and then your polynomial is going to go inside. So if you already are a big fan, you're going to love it. you can go ahead and continue on. But if you are not, push pause along the way just to make sure you understand all the steps. Okay, so again, our goal is to figure out if this is going to have a remainder of 0. If it is, great. If it's not, then we can say it's not a factor. Okay, so here we go. X squared goes into x to the 4th, x squared times. So I'm going to put that here, and then I'm going to multiply that through x to the 4th, and then x squared. Notice I'm keeping everything in line, so they're all the same degree. And then subtract, which is going to wipe those out, but then I have to bring this one down because nothing was there to add to it, and then x squared, and then we bring down the 3x. Okay, then we start the process over again. X squared goes into 3x cubed plus 2x, plus 3x times 3x, because when I know if I multiply that together, I'm going to get 3x cubed. And if I multiply 3x times 1, I'm going to get 3x. Okay, so then the next step is, I'm going to change my marker here. Don't forget to subtract them. Bring this one down because there was nothing to subtract, and then both other ones canceled out, and then the 1 comes down. So how many times does x squared go into x squared? Well, it's 1 time. And if you multiply that through, we get x squared, and then we get 1. And if you subtract them both, we get 0. So what does that mean? The remainder is 0, so therefore we know that x squared plus 1 is a factor. X squared plus 1 is a factor. All right. So I think we have one more to go, and go ahead and push pause and see if you can do this one on your own. You're trying to find out if x minus 3 is a factor of the polynomial. Okay, and then we can use any method you want. If you love long division, use that. If you like synthetic division, use that. If you like to just plug and chug, you can do that too. Lots of different ways you can do the exact same problem. So synthetic division, you put the 3 in and write all of the coefficients. And it looks like we are not missing anything. Drop the 5, 15, 19. Oh, this already is not looking like we're going to have an equal to 0. Okay, so that's going to equal 57. And then if you add those together, you get 60, 180, 182, 546, and 547. So that remainder is telling me that x minus 3 is not. So x minus 3 is not a factor. Okay, now I do want to show you another method, and I know it's not long division, but at the very beginning of the lesson we did a plug and chug method, and I'm going to show you that it's going to give you the same exact result. So whatever method you like, you may use unless the directions say otherwise. So we're going to plug in the root all throughout, and if you add all of that together, you're going to also get an answer. So go ahead and push pause if you like, and go ahead and find out what that is. And after you look at all my work, I also get 547, which is the same result. So you can either do the plug and chug method, and then this one is the synthetic division, and you can do long division as well, just like the previous one. All right, that's all for today.